So for today's lab, we're going to need some materials. Let's get through it. We need copper sulfate. Now, copper sulfate in its hydrated form is going to be blue. All right, so you want to make sure your copper sulfate is blue in this case. That means it's fully hydrated. We're also going to be using a crucible. Now, these crucibles are extremely fragile. They're made of ceramic and are very, very fragile and can break very easily, so we want to be very careful while utilizing these. We're going to use a clay triangle. This is going to hold the crucible above the flame. We're going to use crucible tongs. Now, these tongs are very important because they are going to be able to pick up a crucible that is extremely hot potentially and move it. All right. Be careful. If you grip these too hard, the crucible can actually fling within it. So you want to use these very gently. The friction that's used to grab these is sufficient even if you're just holding it very lightly. We're going to use a weigh boat in order to measure the mass of the copper sulfate. We're going to use a scoopula to sample it out. Because we're using fire in the form of a Bunsen burner, okay, you want to be very careful if you have long hair or loose-fitting clothing. Make sure you take care of those early. So if you have loose hair, tie it up in a ponytail and tuck it under your shirt. And if you're wearing loose-fitting clothing, you need to either wear a more tightly fitting clothing or simply tie down the loose-fitting clothing as best as possible. That way, if you accidentally come over top of a flame or nearby it, your clothing doesn't catch on fire. So let's talk about how we're going to start out this lab. First of all, we need to collect some baseline data. We need to collect the data of how much the crucible weighs empty and dry. So what we're going to do is we're going to zero out our scale. Once it reads 0, we're going to place the crucible on top of the scale. This measurement will be the mass of the crucible beforehand. Once we have the mass of the crucible by itself, we're now going to want to sample out 2 grams of our copper sulfate hydrate. In order to do that, we're going to take our weigh boat, place it on the scale, and zero the scale. Once the scale is at zeros, we're going to take our copper sulfate hydrate, and we're going to sample 2 grams of it. Now, once we have exactly 2 grams of the copper sulfate hydrate, we're going to add that into our crucible. We can now obtain the mass of the crucible with the copper sulfate hydrate solution. Again, always re-zero the scale before any measurement. We now have the mass of the copper sulfate hydrate and the crucible together. Okay. And we're going to follow this up with our next step, which is going to be the heating of our copper sulfate. Now, by heating it, remember, we're removing the water molecules. So think about how that we would expect to affect the data. So what we're going to do is we're going to set this up on top of a Bunsen burner inside the clay triangle. So I'm going to show you how to set that up next. So once we're ready to actually light the Bunsen burner, what we need to do first is make sure that we have the correct setup for our ring stand. So let me show you how we do that. First things first, we want to make sure the ring is at the proper height. We always do this before we light the Bunsen burner because once the Bunsen burner is on, the ring is going to become very hot very quickly. So we need to make sure that the ring is not extremely high above the Bunsen burner because we want our flame to be compact because compact flames are safe flames. The higher the flame, the more danger that can occur. So now what we need to do is once we get the rings to the correct height, we're going to lock it in and we're going to place our clay triangle into the ring. Now notice how the clay triangle's arms are slanted upward slightly. This allows the triangle to nestle into the actual ring itself, which keeps it more stable. That's more safe. We can then place our copper sulfate and crucible into the clay triangle. Now, once it's there, we want to make sure it's 100% sturdy and stable. And if it's stable, then we're good. We're no longer going to be touching this crucible with our hands because from here on out, we're going to assume that it is hot. We need to light our Bunsen burner. In order to do that, I always like to remove it from underneath. And the reason I like to remove it from underneath is because, again, if I light it and the flame is too high, I don't want it to immediately engulf our crucible. I would like to make sure I control the flame outside first. So I'm going to light the crucible using my striker. Always I hold striker in one hand and I control the gas in the other hand. Once our Bunsen burner is lit, Notice how the flame is already fairly low. You can always adjust the flame if you need to, but this is the flame I would like. We don't want too much yellow in the flame. A yellow flame suggests that it's too cool, and even a cool flame, you might see incomplete combustion. With incomplete combustion, what you might end up with is soot on your crucible, which changes the mass in the end. We're going to place this very carefully directly underneath the crucible. Okay. Again, adjusting the height as needed. Once it is there, we are going to let it continue to burn until we see a complete change in the color of the copper sulfate. It should go from blue to white. So at this point, we have already let the Bunsen burner go for 10 minutes, and as you saw, the color of the copper sulfate hydrate went from a very bright blue to a very pale white color. This suggests that the water has been evaporated out successfully. However, we can't assume this. So we've let it burn for 10 minutes, and now we need to turn off the Bunsen burner. And we're going to let it sit for a period of time until it is completely cooled. If we ever put a hot crucible onto a balance directly, the scale will either, one, read incorrectly because of the convective air currents around the crucible, and two, it's a safety hazard because this crucible is several hundred degrees at least, which means that we have to assume that it will burn us very badly should we touch it. Should it fall, should it shatter, now we're talking about extremely hot pieces of ceramic flying across the room. So we want to wait until it's completely cool before we do anything else. So we're going to wait until that happens. So once you've waited until the crucible is completely cool, what we're now going to do is transfer it onto the balance. A couple of techniques that are really important for this. Number one is we never touch it with our hands after it's been over top of a flame. You never want to assume that it's completely cool. All right, so from here on out, we're always going to handle it with our crucible tongs. With our crucible tongs, we're going to grab the corner of our crucible, and we're immediately going to pick it up and drop it down till it's very, very close above the actual tabletop. The reason we do this is because if it were to drop on accident, the fall is much less. If we were holding it higher and it were to accidentally fall, you could cause it to shatter, which can be very dangerous. Here, the likelihood of shattering is much, much less. So what we're going to do is we're going to transfer it over the tabletop at all times. If you bring it over the floor, again, you increase the risk of it dropping and shattering. We're going to move it on top of our balance. So we're taking our cooled crucible, we're placing it directly onto an already zeroed out balance. If it's not already zeroed out, make sure you hit 0. Place the crucible on the balance. Once it's there, we measure our data. This is going to go right into our data table. Once we've done this, we're going to place the crucible back onto the clay triangle, and we're going to perform our next burn. Now that we've measured the mass of our crucible after the first burn, we're going to want to burn it again. This time we're only going to burn it for 3 minutes. The first time we did 10, this time we're only going to do 3. The reason is because we've theoretically gotten rid of most, if not all, of the water already, and so now we're just going to ensure the fact that it's gone. We're going to place the crucible again very carefully on top of our clay triangle. We're going to remove the Bunsen burner from underneath the crucible. Striker in one hand, gas being controlled by the other. Lighting the Bunsen burner. Placing it back under the crucible for 3 minutes. All right, 3 minutes has passed. We turn off the Bunsen burner, we remove it from the crucible, and we again let the crucible cool until it is completely cool so that we don't put a hot crucible on top of a balance. Now that the crucible has cooled sufficiently once again, we're going to do the same thing as we did after the first burn. We're going to pick it up, we're going to transport it over top of the counters only, and we're going to place it back on the balance to get the burn, or to get the mass of the second post-burn hydrate. So after our third burn, we're going to get the mass of this hydrate one more time onto an already zeroed out balance. We record the mass of our hydrate. Once we get this mass, what's going to happen is we are going to be completely done with this. We take it off the balance. We let it cool absolutely completely. Once we do this, we can dispose of the copper hydrate. We take our crucible, we make sure it's completely cleaned out, and we let it sit on our countertop. Do not put water in or on the crucible. Water can be absorbed into the crucible and can actually effectively cause it to crack in the near future. So we don't want to use water as best as possible on the crucible. So we like to scrub it out without water as best as possible. Let's talk quickly about why we need to do 3 successive burns of this hydrate. As you burn a flame underneath the hydrate, what's going to happen is the water molecules, which are associated with the copper sulfate, are going to start to evaporate. As that happens, we're going to have an original mass of our compound, which is going to decrease. So our first burn, we're going to see a dramatic decrease in the mass of our compound hydrate. Now, once we do that, we do not know, even after 10 minutes, if we fully removed all of the water. So we're going to do a second burn. If we see a greater decrease in the mass during our second burn, what we're going to say is, well, clearly we did not get all of that water out because the mass kept going down. So there were still some water molecules left in our hydrate here, which you can see by this secondary change in mass. So we do a third burn. Now if you notice, the mass of the third burn is the same or very, very close to the mass after the second burn. This suggests that after the second burn, we had successfully removed all of our water, and that is confirmed by the fact that after the third burn, the temperature, the mass hasn't changed dramatically. Be aware, if you accidentally overheat your hydrate, you can actually cause the copper sulfate itself to decompose, forming a gas, which can actually decrease the mass as well. So if you overheat it, you might see a slight decrease in mass, not due to water, but instead due to the decomposition of copper sulfate. So be careful as you're heating it, because you want to make sure that you don't overheat. You want to heat for exactly the amount of time we've allocated out, and you want to make sure that you don't overdo it. So if you see 2 numbers that are identical, you don't have to continue again, because that suggests that all of the water is already out. This means that if after the second burn, you don't see any change between the mass of burn 1 and the mass of burn 2, you can simply stop recording after the second burn. Now let's talk about some of the data you're going to be collecting. At the very beginning of the lab, we measured the mass of the crucible alone as it was empty. That is going to be the mass of your empty crucible, which is going to go here. We then added our copper sulfate hydrate to the crucible and measured a new mass. That goes here. Once we did that, we subtracted the mass of the crucible alone from the mass of the crucible and the hydrate, and that's going to give you the mass of your hydrate to begin with. We followed with 3 successive burns. Now the 3 successive burns, remember, is because each time you do it, you don't know if you got all the water out. We needed to look for evidence, which we discussed already, as to how the water is guaranteed to be gone from our hydrate. So this is going to be the mass after the first burn, the mass after the second burn, and the mass after the third burn. Once we found that value, the mass of the anhydrous copper sulfate is going to be calculated given the mass of the original empty crucible and the mass of the crucible plus the hydrate after the third burn. So again, this is going to be a calculated value. We can also then calculate the mass of the water by identifying how much the hydrate to the anhydrate changed. So again, we're going to need to make sure we're calculating our values correctly. As a result of this, we are then going to need to figure out what is the percentage of this original hydrate which was water, and then identify the chemical formula of our hydrate utilizing the same techniques we used in our percent by mass video. If you need a review how to find percent by mass of a hydrate, go back to that video and review that concept. So that wraps up today's lab. Remember, safety first. Today we're utilizing a Bunsen burner, which means you want to come into the lab already ready to go for safety. Hair needs to be back in a ponytail. Loose-fitting clothing needs to make sure that we are tied down or taken off. Now, this lab is going to have a number of places where error could have occurred. So as you perform this lab, make sure you think about where each point of error could be and think about the effect that might have on your end result data. The goal of this lab is to find exactly what the formula of our copper sulfate hydrate is. We want to know how many water molecules are associated with each copper sulfate formula unit. This means that we're going to have to do some mathematical calculations. Remember, if you need to go back and review any of the prior videos that we've watched before this lab, do so now so that you're fully prepared to complete the post-lab questions after the lab is complete. I'd like to thank Nate Roberts for writing, filming, and editing this video. Thank you guys so much for watching it. I'll see you in the next one.